So let's finish off with a tricky example. So this last one is the integral of cosine squared x sine squared x dx. And this is one that you might think that you would want to do a u substitution. So let's start off. Maybe I'll use my black pen to differentiate, sorry. Let's set our u equal to sine of x. Then our du would be cosine of x dx. So things are looking pretty good. So we could isolate out one single cosine, and we would end up with, to get our du by itself, we end up with cosine x times sine squared x times cosine x dx. So this could be our u, or our du. And the problem is that not everything here is in terms of sines, which is our u. We have this one remaining cosine, and we don't have an identity to turn cosines into sines. We only have an identity to turn two cosine squareds into sines. And it turns out that because this cosine is raised to an even power, this type of u substitution isn't going to work, and we're going to have to be a little more clever. And I mean, even I could go as far as to convert this u in, and I'd see that I would get cosine x times u squared du. What do I do with this cosine x? There's nothing I can do with it. So let's go back to our table and see if there's something helpful. And it turns out, well, I have a piece that looks something like this. So let's see if we can make use of this particular trig identity. This isn't integration. This is just a known fact about trig identities. So going back to our original problem, we can see that this integral could be rewritten as the integral of cosine x sine x all quantity squared dx. Why am I allowed to do this algebraic step? This is because cosine squared is just cosine times cosine, sine squared is just sine times sine, and unlike if the terms were separated by a plus sign when you would get middle terms, this is just cosine times cosine times sine. When they're all factors, then it works out nicely. So now I can apply this substitution. Sine 2x is equal to 2 times this. I'm going to divide both sides by 2, and I can simplify this into 1/2 of the sine of 2x all squared, which in turn becomes, I'm going to distribute this squared. Again, each of these terms is multiplied by each other, so 1/2 squared is 1/4. I get sine squared, and I'm not distributing the 2 into this because this is not a separate term. This is a function of sine, and thus we end up with sine squared of 2x. There are a lot of arithmetic mistakes that I see on problems like these, so I want to highlight some of the arithmetic as I go. So maybe this is better, but it still doesn't look like I have a u that I can work with, right? Because now I only have sine, and if I change this into 1 minus cosine, I would only have cosines. So we're going to have to, so this was one trig substitution, right, using this trig identity, and then we're going to have to do it again. We're going to change the, we're going to use the fact that sine squared x is equal to this mess. So let's, I'll write this up over here. So I'm going to pull the constant out front. This is just 1/4 of the integral of, and again the identity says that sine squared of x is equal to blah, but it's not sine squared of x in this case, it's sine squared of 2x, so I'm going to replace x by 2x, and that makes this a 4x. So this is the integral of 1/2 of 1 plus the cosine of 4x dx. And I can pull the 1/2 out, so I get 1/8 times the integral of 1 plus the cosine of 4x dx. Why is this good news? Because cosine is something that we do know how to integrate. Cosine squared is tricky, but cosine on itself, integral of cosine is just sine. We are going to have to do a u substitution because it's not x in here, it's 4x, so that's a pretty easy step. So I'm going to let u be equal to 4x, because then du is just equal to 4 dx. So I'm going to need to convert this by adding a 1/4. So I have 1/8 times 1/4 times the integral of 1 plus cosine of 4x. I multiply it by 1/4, then I get a 4 dx. This can convert into my du. I get 8 times 4 is 32, times the integral of 1 plus cosine of u du. I can integrate 1/32. I'm integrating with respect to u, so my 1 becomes a u, and the integral of cosine becomes sine of u plus c because of the indefinite integral. And in my final step, I plug in my u again, and I get 1/32 of u was equal to 4x plus, this all becomes sine of 4x plus c. And we're all done.